So we are recording and it is 7 o'clock on the dot. So we might as well get started in talking about today's presentation or our next presentation for the day, depending if you've been attending any already. But this is session 504, Improving Mathematics Learning Through Computational Participation. And this is a project that involves the STEAM 3D Maker Lab in Ontario Tech University. So we'll talk a little bit about what has been going on. It is actually an ongoing project, so we're still working on it, but we wanted to share some of what we've done so far and kind of just different ideas that we've had and things that we've done with both teachers and students. So just to get the ball rolling a little bit as I admit people into our classroom. So if you're comfortable and you feel like sharing, let me know in the chat what your background is in education or professionally, and where are you coming from? Where are you tuning in from? Are you a grad student? Are you a BEd student, a BA student? Are you an active teacher? Where are you coming from? Just to get the ball started, you don't need to come on mic for this, chat box is fine, but I am currently a master's student at Ontario Tech University, but I am a teacher as well. So my background is in biology and general science, which is funny because, I'm doing a presentation in math. Ooh, we have some BEd students, we've got full-time teachers. Ooh, we have a high school teacher that's now a professor, which is awesome. A math curriculum leader at TDSB. That's great to hear. Diane, our wonderful Diane, who's leading all of us in this conference, is here as well. Teaching math and coding. Teacher at TCDSB. A BA student from Newfoundland. That's awesome. My whole family's from Newfoundland. It's nice to see that we have people from all over Canada that are attending. I live in Ontario, but whole family's from Newfoundland. A tech lead, which is awesome. Instructor at York U, future D candidate at Ontario Tech. That's exciting. Starts up in the fall semester, so in September. Future BEd student, welcome. Hopefully you get to learn some things and things that you might be able to take with you as you move through the BEd program. So thank you for sharing. That was awesome. It's nice to see where everybody is coming from and what all of the backgrounds are, because it's always really diverse and it's kind of neat to see all the different career paths people have taken over the years. So just to give you a little 411 as to who is involved in this project. This is a project through the STEAM 3D Maker Lab, like I mentioned before. It is run by Dr. Janette Hughes, and both myself and Dr. Zainab Geku Permaxis, I always slur a little on that one, who is our postdoctoral fellow at the STEAM Lab. We have all been working on this project for almost a year, going on into a year. So it's been for almost a full school year at least. And we're going to talk today about the different things that we've done with teachers, the pedagogies that we've included and kind of built into this project, and what we've done for teachers and students alike, because it's been a multifaceted project. It wasn't just a one and done kind of thing. Just adding some more people into our chat. But just to give you a bit of an overview, I'm not going to be talking the entire time because I know how terribly boring that is, and that's a bad teacher thing to do, is just to talk at you for 40 minutes. That's no fun. So we're going to talk about making and maker pedagogies, coding and computational participation. We're going to talk a little bit about the project details and the timeline for this project that we've been conducting for the last school year. And we're actually going to do some activities as well, because I like hands-on learning, and I think it's very useful for both me as a teacher and to help other people understand what we've been doing if you get to play around with what we've done as well. So I have two activities set up for us. One is going to be an activity that we did with teachers, so that way they could learn a little bit more about Scratch. And then the second is also a Scratch activity, but we did it with students, particularly a kindergarten group. So we'll get to play around with that a little bit later. And then, of course, we'll have a little bit of time at the end for Q&As. But if at any point in time you have a question and you want to just get it off your chest, just so you don't forget about it, please pop it into the chat. Let me know. I'm a chatterbox, so I can keep going, but we can always stop and talk because I love your questions. And I think we might have some interesting questions that come up from this project. So just to talk a little bit about what making and maker pedagogies are, this sometimes is a little bit of a new word or a new idea for some people, but it's really what the STEAM 3D Maker Lab integrates into almost all aspects of teaching and learning. And to sum up the maker movement, we have this lovely quote from Halverson and Sheridan, which is the growing number of people who are engaged in the creative production of artifacts in their daily lives and who find physical and digital forms to share their processes and products with others. So that quote really sums up what maker pedagogies are. So they tend to be student-centered, they're active learning, they're hands-on learning. It has a very collaborative learning piece integrated into it all. It can be inquiry-based, and it really involves the creativity of students and to integrate problem solving as well. So it's not just making something for the sake of making something, but to kind of expand learning through making. So why did we do a project about computational participation, which we'll talk about what that is exactly in coding and math? Well, if you have been actively teaching or if you pay attention to the news too, in the last year or two, coding got integrated into the math curriculum, which was a bit of a head scratcher for some people who have never coded before as to how do we teach coding to grade 1 to 8 students, but even to kindergarten students, because some boards decided to do so. And this is just kind of a really quick overview of what the coding expectations are specifically for each grade, but just to give you a sense of what was needed to be taught to students and what we kind of used as the basis for creating some of the activities that we've done for students. So why does coding matter? Because it's just this weird thing. If you're like me, you kind of grew up thinking like, okay, coding is for people who want to design computers and all this kind of stuff. Why are we teaching it to students who are 13 and under, even high school students? What's the point? Well, coding itself is a literacy skill. It can be very creative. It allows for collaboration. It can be very social in the sense that students can work together and talk about problems that they're having and help solve things together. And different types of platforms allow for encoding, like Scratch, allow for this collaborative learning experience where they can remix and share their code with each other, with their classmates, or even people around the world. And coding in a nutshell is all about understanding, changing, and remaking the digital world we live in. We're not trying to teach a whole generation of students how to be a programmer. That's not what it's all about. But we want to teach students that through coding, they can integrate different ideas. They can expand what they've learned. And all of the things that students learn through coding translate really well to develop 21st century competencies, which are vital for students moving forward into high school, into adulthood, into post-secondary, into their careers. So I've said the word computational participation a lot, and if you're like me, it might be a brand new word. It was when I started this project. But this computational participation is an idea that was developed by Yasmin Kafai in the States. And it's the ability to solve problems with others, design systems for and with others, and to draw on computer science concepts, practices, and perspectives to understand the cultural and social nature of human behavior. That's kind of a mouthful. And it's kind of like a little complicated, right? What Yasmin Kafai was trying to state here and to build an understanding of computational participation is that this evolved from computational thinking, which came from Seymour Papert and somebody who she actually learned under. And computational thinking tended to be this thought process that surrounded computer science really heavily. But Kafai wanted to incorporate other subjects. So not just to be computer science based, but to make it more STEAM-based in that sense. So integrate art, to integrate literacy, social sciences, math, anything and everything you can think of can be integrated and taught through computational participation, which is kind of the groundwork that we use to help develop and build activities and to develop the professional development sessions that we had for teachers through all of this. So 3 of the key shifts that we kind of saw and that were developed and found through Kafai's work is that youth are now learning about computer programming are that they move from building code from the ground up, so from scratch building, to creating shareable applications and sharing it with each other and with the world. They're moving from tools in singularly and independently to these communities of tools that are used to interact with others and with each other. And it's that transition from scratch creation to remixing. So if you have any experience using Scratch as a coding platform, remixing is something that you can do where you take a previous person's code, you remix it, and then it allows you to edit it. And then you can eventually share that as well. So this whole shift in kind of how students are learning and what they're doing with coding is very important to developing those 21st century competencies and also helping them build their understanding of other subjects as well. So to talk a little bit more about the actual research project, that's what our next few slides will do. But our research questions that we had 3 that we are starting with. And it's to identify the ways in which teachers can meaningfully integrate computational participation when teaching mathematics, to identify the curricular and real-life learning opportunities students gain when they use computational participation, and to explore the environments where CP, computational participation, might foster deeper understanding and learning. So that's what we set out to kind of start to figure out, to collect data on, to do activities with teachers and students to see what exactly could be developed from using computational participation. So this project, as I said, has been on the go since September, but we have 2 partnered school boards, one that is located in somewhat central Ontario in the Durham region, as well as one in Northern Ontario. So I'll show you a timeline in a little bit, but essentially what we worked on is we created 5 PD sessions per board, so 10 in total, that were directed towards teachers to help build their learning and understanding. We created essentially a virtual makerspace where we would post materials, we'd do live sessions, we'd answer questions, and it allowed for both synchronous and asynchronous learning to occur. From each school board, we had 5 teachers for 10 in total, and they represented kindergarten to grade 8 schools. Each teacher had approximately 20 students, though there was a little bit of variance in that. And for each of these 10 teachers, we co-facilitated sessions and enacted them in real time. So most of them were virtual with 1 in-person session, but we co-created and co-facilitated these sessions with teachers. So what that means is that we didn't just tell them what we wanted to do or what we wanted to teach the students. We took an idea that they had a curriculum connection that they needed to address, and we worked together to build an activity around it. So in some circumstances, we used the idea of building cities and towns, and we built houses, which is something that you'll see in a little bit. Another activity, we actually created a programmable AI classifier to help sort healthy foods versus unhealthy foods. And students actually took that a step further and created something that would sort foods that they were allergic to and foods that they weren't allergic to. And all of these things use different types of coding. So whether it was a virtual coding or if it was a hands-on technology that used coding to help develop skills, but we started where the teachers the level that the teachers were at, we helped build their competencies and their understanding. And we also used the technology that was available to them. So to give you an idea of what I mean by it's been the last school year, this is kind of the timeline that we've been working with. The PD session started in October. They were scheduled to wrap up in January, but I think they actually got pushed a little bit further, almost into March, due to COVID restrictions and different things that happened. We started our in-class co-facilitations in February, co-creating and co-delivering those lessons in real time to provide support to teachers and students. And we are actually just wrapping up our co-facilitations, I believe, this week. So this has been a very ongoing project of really new ideas that we've been creating. In June, we will be conducting group interviews that occur with teachers to kind of see how did they feel about all of the activities and so on, and how did their students do moving forward. And then we work into the data coding and transcribing, which is always the super duper fun stuff. So what kind of was the point? Like, I'm telling you all this information about projects, like what are we hoping to achieve at the end of this? And these are implications pedagogically and professionally. So what we really wanted to do is we wanted to help address the new learning needs of Ontario students in mathematics, because like I talked about at the beginning, we had new coding expectations that came through, and teachers in some cases were struggling how to teach these things. We had just come back from almost a whole year of virtual learning, and now we're back in person, and now we have new expectations that we have to make sure we address. It was kind of it got a little sticky sometimes. So we wanted to be able to support the learning of both the students and the teachers to help meet the curriculum standards. We want to see how computational participation supports real world learning and digital making. Computational participation is not something that is often studied in the literature. So this would add to the growing body of research. And we really hope through that this study that it helps to enhance teacher practice in mathematics through the PD and the co-facility lessons, and helps to build the 21st century competencies of the students. So that's enough talking for me, because I've just talked your ear off for 18 minutes, and I'm sure you want to get your hands dirty playing with something. So what we're going to do is we're going to first look at a professional learning activity. So this was something that we did with teachers in both school boards that we conducted synchronously and asynchronously. And it involves looking at the sums of growing and shrinking numbers through Scratch. So into the chat box, providing that this works successfully, and it does, I have popped a link to a Scratch, I almost called it a game, but a Scratch activity. And if you open that link, you will get something that looks somewhat similar to what my screen is now currently loading. All of these activities, or at least two of these activities, were created by Dr. George Gannidis, who is a former teacher and math expert who works out of Western University, and he's also a co-investigator on this project. So if you open up your Scratch, you might want to pull the list down because one of them tends to hide itself. You'll get something that looks like this that you see on my screen here. Increase the size a little bit. And when you run it, you create two number lists. The first one is just a number list, kind of plain and simple, runs 1 to 4. And then the second is a sum list. So it adds the sum of the two numbers that were used in the next sequence. Now, this code can be used directly as is, or you can provide challenges to students, which is what we taught teachers to do in order to expand learning and kind of in their understanding. One thing that I always like to do that you're more than welcome to do as well is to go to the control button, which is kind of a orangey, dark yellow looking button, and plug in a wait 1 second block, because it slows down the creation of the number list. It kind of helps you see and visualize it a little bit better. 1 second is a little slow for me, so I'm going to change mine to 0.5. And as you can see by clicking our green flag, if you've never used Scratch before, that allows the coding sequence to start and for our number list to get populated. So just popping back to my slides, what students can do with this code is that they can actually edit it to create different lists of numbers. So if we wanted to create a list of all odd numbers, how can we do that? Using this code, what would you need to change or edit in the code sequence in order to create lists of odd or even numbers? How can we predict their sum? How can we edit the code list to get more numbers if I wanted to do all the way up to 19? What do we see about the sums of odd numbers? They're square numbers. How do we edit the code to get numbers like 11, 22, 33, 44? Can we predict their sums? All these things don't require students to build a code sequence themselves, but allows them to edit the code, which is an actual curriculum expectation. So if you've been following along thus far, you can kind of see what I will be doing to create different lists of numbers. If students are brand new to coding, a really good thing is to kind of work through what each of the code options mean. So picking a couple blocks, what does this first block mean? When the green flag is clicked, what does that mean? Where do we find it? And helping them to recognize the colors and what the words mean in the code block so that they can help start editing things on their own. So if I wanted to create a number list with all even numbers, how could I do that? Well, I could start my number sequence off with 0, so set number to 0. And then if I look through my number sequence, I can see that I'm changing the number by 1. So what if I change that to 2? And that's a great point, Diane. So users can right-click the blocks and add comments about what they can do. So if you wanted to add notes, my screen is a little tiny. You can add a sticky note that helps to explain what each block does. And this is something that you can set up in a classroom, or you can set up, get students to fill in as they go to help make little notes for them to understand. So I started my sequence off with 0, and I'm changing by 2. So if I click my flag, I can see what happens. Now I've created a number list that starts with 0, but shows only even numbers. What if I wanted all odd numbers? Well, I could start with 1, add 2 each time, and now I have lists of all odd numbers. Well, a number list of all odd numbers. And by creating different number lists, you can kind of start to gauge student understanding and like, well, what do square numbers mean? What do odd numbers look like? How do I create different lists of numbers? How can I make a longer list of numbers if I'm trying to reach very, very large numbers? Maybe I want a sum of almost 100. How would I get to that number? And a really useful thing with creating these number lists is that students can also take what they create in the code and graph them. So if they're graphing the number list and they're graphing the sum list, what do those graphs end up looking like? And this can be something that you use with students who might be a little bit older, so maybe not necessarily grade 3, 4, but towards grade 6, 7, 8. Just to see, well, what do the different graphs look like? What if something is increasing the same each time? So it increases by 2 each number, like in our number list, whereas our sum list doesn't increase like that. So getting students to recognize these things and to create graphs, both of those are curriculum expectations, and that can help them build their understanding of math a little bit better through coding and Scratch. There's also other activities that you can engage with students. So how do you find the sum of the first 100 odd numbers? How many odd numbers do you need to add together to get a sum of 400? What's the formula of the sum of odd numbers? So starting to look at formulas as we get a little bit higher. And this is what I created on the code that we see here. So I started my set number at 1, and I increased by 2 each time. And I changed my repeats to 10, so I get 10 numbers in my number list. I'm just going to take a minute so we can like catch our breath a little bit. See if there's anything to play with. If you have any questions about the code or about Scratch in general, please feel free to come on mic or pop it in the chat. We'll take a minute before we move on to the next activity. I see a hand.
Hey, Devin, it's me, Sultan, in the chat.
Hi there.
Hey, so my biggest concern, and this is a concern that is, it's an agitation, is when boards kind of come in with the swooping fist and say something is a compromising tool. It's either data collecting or whatever. They make something up where they basically, not make something up, but they say something that withholds us from using the tool. I know this happened in the school district I'm affiliated with just this past year. It was temporary, don't get me wrong, but there was like a full, a full stop on the use of Scratch. What are some options, at least when it comes to Scratch coding, through MIT's tools that we can have as a backup plan, just in case Scratch is put on temporary hold?
Right. So Diane just put in the chat too, which is a useful thing that may or may not work. I don't know, depending on the board restrictions, but Scratch can be downloadable. So if you download the application itself, it prevents it from needing online use, because that would stop it from being shareable then. But a lot of, so no social online is what Diane is saying. I see in the chat, there's another one that I actually have not heard of. So CS First, which is Scratch-based and circumvents the privacy issues, which is another great tool. But essentially a lot of block-based coding applications can be used. I know another one that requires online learning, but that does kind of work as well. There's like CoSpace's EDU, which is block-based.
That's a paid for
Microbits,
subscription though, no?
that one is, yes, but they do have a free version that you can use. It's just kind of limited a little bit, but you can still code with it. Using Microbits, but through the make code, that is another block base that works. But
these are good ideas. Yeah.
Scratch is really unique though, which the downloadable route might be the best option, just because I have not come across one, a coding application that can do as much math as Scratch can do, because other ones get a little limited. But I've seen people be able to create, and this is actually from Dr. George Gadanitis, like all kinds of variables that you can create and lists that you can create. And it's really, it can be very math oriented, but also very not, which is why Scratch tends to be the preferred and majorly used one.
Yeah, no, thank you. And I appreciate its usability on Chromebooks as well, which seems to be the go-to accessible tool in the classroom. But yeah, thank you for that.
No problem. So Diane is saying CS versus Scratch with some limitations that allays some concerns about online sharing. So much math is developed intuitively through Scratch. Yeah, it's interesting to see, because I haven't actually seen very many tools that do math as much as Scratch can do, which is funny. But we'll see. So while we're still digesting and thinking, I want to show you, before we get into our next Scratch activity, which will be also a little fun to play with, I'm going to show you something that I did with students in a classroom. I don't have it set up for you to interact with it directly because it takes a little bit of groundwork in the beginning. But this was an activity that I created for a grade 3 classroom through Tinkercad. So if you're familiar with Tinkercad, it is a 3D modeling online tool that allows students to create 3D models that can actually be exported and 3D printed, though that's not actually necessary. but a really new application for Tinkercad is called Code Blocks. So it incorporates both 3D modeling and coding together and allows students to create things through coding. So instead of needing to be able to manipulate all of the numbers and features and buttons that are involved in Tinkercad, they can actually code for these things to work. So this is a class that was doing work on houses and what communities look like. So I created a very basic code that would create a house that you see being created in the GIF that's on the right. So this house is very simplistic. I gave it a little nameplate and some bushes. It's got 2 windows. It actually has 2 doors, but their version only had 1. But I created this it looks like a long code, but it's simplistic in a sense. And I pushed this code to the students. So I created a classroom. They all copied and remixed it. And I said, from this, we're actually going to create something. We're going to get a little bit more. We're going to add some things. I want you to get creative. So they named their house and created a nameplate. Like you can see, mine's just called Devin's house, but they created a new name that would reflect their personality in their house. They added bushes. Some students created furniture. You'll see in the next slide, some students actually created stars to hang over their house to represent the night sky. And students got really creative. And we also made the house bigger, which was something else I'm going to talk about. So here we can see some student examples that we have permission to collect for. So some students really took their house and gave it like a winter theme. Some created grass to go with their house to create a yard for their house. This one on the bottom left kind of looks like a funny face, but it's actually a top-down view of their house, just because I wanted to show the stars that they had created along with the bushes and what is actually a chimney that they were developing to go with their house. And one of the questions that I posed to the students is, how can we make our house bigger? Because we created a very tiny house. Might be good for 1 or 2 people, but what if we wanted a large family? How can we make something bigger? And my intention with this activity, which just goes to show the creativity of students, is that I just wanted them to expand the house, to make it a little bit longer. But other students said, well, what if we made a second floor? What if we make it bigger in that way? So I said, that's a great idea. Let's take that and roll with it. Let's create that together. So we actually ended up creating a code to add in that would create a foundation and to create a second floor in our house. And we cut out new windows so we could have light, so to speak, and to make our house bigger in that way. But we also expanded it lengthwise as well. And this bottom picture that you see down here is a reflection of that code that we created together during a co-facilitation with grade 3 students. And one of the remarkable things that came out of this project, at least for me, was the language that students were able to develop through this activity. We were talking about how we can scale different models and make things bigger or smaller. We were talking about coordinate systems and how we move things through our makerspace and where we were 3D creating this house. And to see students use that language and use the variables to help their understanding, to teach each other about where things should go and where things should move to at a grade 3 level was really remarkable. And it was interesting because it was the first time that they had ever seen this, yet they were able to pick up and use the language and understand the language. And the really great thing about this too is that using Tinkercad and code blocks, you can create classrooms and set them up so you can access student work and see what they've created. So our final activity that we'll work on for the next probably 5 or so minutes is a co-facilitation activity called Making Number Sentences with Sequential Scratch Code. And this activity was put forward to a I think it was kindergarten to grade 2 class, I think was about the age range of that group. So we'll see what we did here. Let me just copy this. So if you click on the link to that code, you will open up something similar to what my screen is currently loading. And it is a super duper simplistic code, but it's really cool what you can do with this. So this code was set up so students didn't need to edit anything. We wanted it for a very young group of students who weren't necessarily at reading level for the language that's involved in this type of coding. But we wanted it to be as simple as possible so that they can create things and then also give them time to expand and explore and play. So if you just kind of play around with this code, you can see that if you click the bottom code sequence, you can stamp a green dot. If I click the middle sequence that's labeled yellow, I can stamp yellow dots. And then by clicking the very top one, I erase everything. So this is very simple. It's a very simplistic code and it creates something very simplistic. But what I wanted to do with these students is to work on building number sentences. So to help them recognize if I'm adding two numbers together, what am I getting in total? For this, I gave them the scenario of I want to have a number pattern with 5. So I'm going to stamp 3 yellow dots. I'm going to stamp 2 green dots, and this will give me 5. And I actually had a worksheet set up for them that they could fill out as they go, and they could create different number sequences, number sentences to reflect a certain number of total dots. This could be different things that add up to 5, different things that add up to 6, 7, 8, 9, 10, whatever works for the students. But I wanted them to be able to see what different things can add up, what different numbers can add up to the same total. So I think for this activity, we actually worked with 8s. So what would it look like if I did 1 yellow dot, and then I've got 7 green? You click and drag your dot down. Now let's try 2 yellow and 6 green. And you can start to create patterns, which is what Diane pointed out. So there's a lot of different patterning possibilities that students can pick up on with this activity as well. They can start to recognize patterns that are created through this coding. And so on and so forth. So as students worked on this, I also worked with them and created different patterns so they could see what could be created, and then gave them the opportunity to create these patterns themselves. That is not the right code. So this was just a very simplistic worksheet. They had about 12 opportunities to create different number sentences, and they could switch up the number once they exhausted all the possibilities. And then once we had created all of our number sequences, we talked about the different patterns that you can create with the same total number of dots, which is really interesting to see what they can create different pattern-wise. And one of my favorite things that I love to do that I find so important when you're doing coding activities with students is to give them the opportunity to play with the code that you've created. So in this case, I gave them the opportunity to just play around with the code and see what you can create, see what you can add to. This class had some experience with Scratch, so they were familiar with different blocks. And I got to watch and see how students would manipulate the code in such a way where they would have their dot move around the screen and stamp automatically. So this is something that is a drag and drop stamp, but they were able to get it to move into random locations and stamp automatically. And this sounds like such a simplistic thing, but this is like a kindergarten class that are able to manipulate and edit current code to do something completely different, which is an awesome example of that collaborative and communication in learning. So it is just about 7:40 according to my clock, which puts me right at a perfect time. And hopefully you've had some fun. I want you to have fun with this and to be able to play around with the different coding applications and activities and kind of learn something new about maker pedagogies and computational participation. But if you have any questions, please pop them in the chat. Come on, Mike, whatever works for you. I'd love to answer your questions if you have any. If not, that is totally okay, and you're more than welcome to leave the session. If you ever do have questions at any point in time, though, you can reach out to us. We have an Instagram and a Twitter at the Steam 3D Maker, at Steam 3D Maker Lab. And our website is janettehughes.ca/lab. My email address is also listed on the screen, devin.flynn@ontariotechU.ca. And I had to make sure I actually spelled that right. So please feel free at any point, if you have questions, reach out, give us a shout, or give us a follow. I see a hand.
It's Diane.
Hi.
So thank you very much. Really love the activities. Those are a couple that I had never seen before. I just wanted to point out to people about how much math is being done intuitively. So things like coordinates, well before they're ever in the curriculum, that kids are learning intuitively and making sense of them without direct instruction often. Kids in grade 5 will thank teachers for showing them variables because now they can keep score in their coding. And, you know, I don't think we can stress that enough about how much with these playful environments, kids can learn math that we can then link to the more formal math when they have to learn the more formal math, the symbols and things like that. That's just my rant as a teacher of math and technology.
Yes, and a fabulous coding instructor, if I do say so myself. Because Diane taught, well, back when I was doing my BEd, she was teaching the coding class. So I wasn't fortunate enough to be in her class.
No, I didn't think I had you, but yeah.
No, but I heard wonderful things and we interacted on other levels too.
Yeah. Yeah.
So I did get a message in the chat and I'm going to answer it on mic because honestly, I don't think I'll have enough time to type it out. And it was regarding Scratch with kindergarten students. So it depends on the level that students are at. If kindergartners can use Scratch as it is. I'm stuttering a little bit. I've used Scratch with kindergartners, but I also sometimes switch over to Scratch Junior. And it really just depends on the teacher's comfortability and also how comfortable students are with reading some of the blocks. Because Scratch as a base level, I still have one on the screen. It's very text-based and there's a lot of language involved. And there's a lot of blocks too. So sometimes students can get very overwhelmed as to what is going on. One thing that you can do though is to start students off slow, work with Scratch Junior first to kind of build up those pre-Scratch 3.0 coding skills. You can do a lot of different patterning and activities in that regard. I have had activities in Scratch Junior where students would create and place different objects around a scene and then be able to count out the blocks that they would need to move their sprite to be able to go to that block or that thing that they created. So in some cases it was shapes where they would get their character to say the name of a shape. In another activity, it was using flowers that they would populate and they got their sprite to move around the screen and do a little jump every time they got to a flower. So it really depends on the age of the students, but I think it depends on your comfortability too. So with the one class that we did the Scratch with, that was a kindergarten class, the teacher took the students through it over the course of a year, kind of taught them a couple blocks every week on coding Fridays. So that way they could build up their understanding and their competency with it. If it's something that they don't need to edit or manipulate too much, students can be really successful in kindergarten with Scratch. But if they need to create from the ground up, Scratch Junior might be the way to go. I see a hand up, and I think it's coming from Ryan.
Yes, hi. I just wanted to ask your opinion of where students might progress to after they've come out of Scratch, like after grade 8, going into high school, or maybe even in grade 7 and 8. Where would their coding go towards with math-based anyways? Or if they were moving on to computer science, which direction would they head?
So Scratch can still evolve even past the grade 8 level. Like it can get super duper complex as they move through. Though what I would actually recommend as students move into high school levels is to kind of start exploring the 3D modeling through Tinkercad and the code blocks, because the language of it is a lot more complex and it starts to incorporate more math terminology, but using a lot more coordinate systems and different types of variables. So it can really help trigger and highlight those important skills that students will need in both math and in like coding. But it's also a really neat skill to develop if they can at a younger age as they move through high school, because 3D modeling is such an important and becoming a very big field. So it's kind of a neat thing that they can start creating through. And it's super duper neat to see what students can create through the 3D modeling. And the Tinkercad code blocks kind of incorporates the best of both worlds, in my opinion, because they can code and they can also 3D model.
Thank you.
And I'm going to add a little bit more if Devin doesn't mind. And I agree about the Tinkercad and the 3D and the importance of spatial reasoning in secondary math, which we have to both develop, but it's embedded in a lot of math and science that is not necessarily explicit. But some people have developed it before high school and other people don't, and then they start to struggle. I was going to suggest there's things out there that are transitioning from Scratch to Python, which I'm going to add. I added what we're doing in the BEd, our support staff teachers. I put the link in there. So we'll add that. So pitch is one of them. So what they're looking at is moving. So you start in Python, but it's using the same words as Scratch, and it pops up. So if you start typing in move, it will pop up in syntax of Python. So I went to a couple conferences last year where they're talking about kids develop superpowers in Scratch, and then when they switched to something something into like Python, all of a sudden they're lost. And how do we build on that? So the Scratch, the Scritch and the Python, I've forgotten the names. I will add them to our site. There are things that people are developing for that. Some grade 9s love Python, but if they don't have a lot of coding experience, I'm recommending, teachers have to make decisions based on their comfort level and their students' comfort level. In math and science, we are using coding to help develop and demonstrate concepts. So there's nothing that says it has to be text-based. And there's some people out there who will argue that, maybe in grade 10, yes, but in our D-stream grade 9 classes, we really want to think carefully about what tool is going to make the course as accessible as possible for students. So those are just a couple, again, some of my rants.
Another really good tool too for transitioning between coding languages is MakeCode and Microbits. It starts as a block-based coding, and then you can actually shift between if you want to look at Python. So you can code it in block and then shift the language to, I believe it shifts to Python. So then students can see like, okay, like I created something with block-based, it works. Now, what does this look like if I move it to Python? So it can be a really useful thing to kind of translate between the two. I worked in a camp once and we actually had I think it was a grade 5 student that would actually do that. So you'd create something in with the block code and then translate it over and then start editing it again, just to kind of play around and see what would happen. There was another comment too, a little bit further up, Sultan. Another really good site that I popped in the chat is learnx.ca. This was actually created by Dr. George Gadanitis. That has a lot of other resources as well that go from kindergarten all the way up through high school, I believe, or at least grade 9. So there's other things that you can do a lot with math and coding. He uses Scratch a lot, but there's other resources that are there as well. And then Microbits I'm very partial to, so I mentioned them a lot, but the reason why they're really cool is because it allows you to collect data. So you can actually set them up to do data collection, and then you can populate it into Excel and then get students to manipulate it and turn that into graphs. So that's why I really love using it, because it kind of infuses science, math, and coding like all together in this perfect little bundle.
Thank you. Thank you very much. That's great.
No problem. And I popped the link for the microbit.org/code into the chat. There's Python editors and make code editors, but you can translate between the two quite easily. This has been lovely conversations today. No problem. And thanks for participating in today's conference, session 504. If you do ever have any questions, comments, concerns, or you want to reach out, look us up at STEAM 3D Maker Lab. We're always available. We've always got resources that are posted on our website too. Thanks for coming.